I hope by now you're convinced that glucose is a really important biomolecule. This is the unit that starts our energy getting process and is something that we need to break down larger pieces into in order to get the glucose there in the first place. We break down carbohydrates into glucose, and because of this, we need to have the right amount of glucose in blood, both to regulate energetic processes, conserve this resource so it's not wasted, and this is achieved by two hormones, insulin and glucagon. And so here's a breakdown of the two and why they're so important. And I would say the long and short of it is that insulin is promoting the storage of glucose. It's going to remove glucose from our blood and it's going to store it as glycogen. Glucagon breaks down glycogen into glucose, so it gets glucose, right? Insulin is the saver of glucose in our blood. Glucagon is the retriever of glucose in our blood. And so these two are, the hormones, right, that are making this effort to ensure that our blood glucose is at the right level, which is very important for other processes. And so the condition diabetes is a condition in which blood glucose levels are abnormally high. And this can happen because there's not enough insulin, right? If insulin is what's in charge of taking glucose out of the blood and storing it away, well, if we don't have enough workers that are taking the free glucose and sticking it in the warehouse, so to speak, there's going to be extra boxes lying around, right? Not enough insulin means that that's there. Or the body can't use insulin effectively. And so, that's sort of the same thing, right? If the workers are not able to be used right, then the effect isn't going to occur. Type 1 diabetes, no insulin production. This is, really largely genetic. You have to bring your own insulin in order to make sure that you are saving your glucose properly and not having spikes in your blood glucose levels, aka your blood sugar. Type 2 diabetes is more common in adults, right? This was once called adult onset diabetes. This is the diabetes that is related to, diet and habits, and it sort of sets on over time. But now type 1 diabetes, this is really that genetic insulin is not created, whereas type 2 is that insulin is becoming less effective later in life. In diabetes, right, we talked about this already. Glucagon, again, may continue to release glucose, and so that may make things worse, right? If only the insulin is affected and not the glucagon, that can make, that sort of getting process is fine. They continue to drop glucose into the blood, but the glucose is not being retrieved properly. And so if we look at blood glucose ranges, right, we have 6 columns here. And so the fasting blood glucose versus 2 hours after eating postprandial in a normal, non-diabetic person, we have the following blood glucose ranges. And then for someone who may be developing diabetes, that's shown there as well. And then a diabetic, what their blood glucose would be. When you're looking at, conditions or markers of blood glucose, these are numbers that you may want to consider. Finally, you may have heard of GLP-1 receptor agonists or GLP-1 medications. These have been revolutionary in the past years and likely will continue to be of interest to people as the medication evolves in how it's administered and things like that. But as far as what it's doing, this is a complicated type of process, but the GLP-1 is a natural gut hormone, glucagon-like peptide 1, and these agonists are mimicking the natural hormone. And when we have this hormone that's part of our gut that's being mimicked, we affect both the insulin and the glucagon, and weight loss is observed. It also slows stomach emptying, it can send signals of fullness to the brain, and all those things can lead to the desirable outcome for a lot of people these days, which is weight loss. But I think that, again, what exactly this is doing, not only is this outside of the scope of the course, but the exact chemical mechanisms are like emerging science as well. It's not like anybody knows exactly what and how much and through what mechanism exactly things are doing. Drugs are proven to be safe through clinical trials and effective, like it will lead to weight loss. But as far as the exact details, that is still emerging. And so when we consider these, I think that they're worth mentioning here because insulin and glucagon are both affected, and these are the really important regulators of our blood sugar This disrupts that, and while the effect is very strong, this was not the originally conceived use of GLP-1 receptor agonists, and I think that emerging science in the coming years may reveal maybe even more benefits or maybe even more challenges associated with them, and I think that the mechanism and the overall system that they are disrupting is worth considering if you ever want to learn more about these medications.